Hey everybody, so here's our first lesson as part of our Earth and Climate Change unit. We're going to be talking about a little bit of terminology to get us started, and we're going to focus on the difference between the terms weather and climate. But before we get going, what I want you to do is quickly think about these two prompts on the screen. So why do you think that climate change is occurring when we have a difficult time even predicting the weather for next week? So if I asked you what the weather is going to be next week, you probably don't have a good idea, but you would probably be likely to say, well, yeah, climate change is occurring. We know we're getting warmer. And think about if it's easier to predict the weather for next week, so what's it going to be like next Saturday, for example, or is it easier to predict what the climate will be like in the middle of July? And you should see that I've intentionally used the words weather and climate there. Even though we haven't gone into a definition of those yet, we will in the next few slides. It should give you a hint as to what the differences are going to be. So when we talk about weather, we're talking about the conditions outside on a particular day, and this includes a bunch of these meteorological terms. So if you watch the weather in the morning or you check your cell phone before you go to school, you should see that these are all the characteristics that we talk about. Temperature, precipitation, wind, humidity, pressure, and then if it's overcast, fog or mist. So as an example, you might hear that the temperature outside today is -5 degrees Celsius because we are in Canada. When we talk about precipitation, there's typically two measures there. We talk about the percent chance of precipitation. So if you're taking a look at the weather app on your phone, you might see POP. And we talk about how much, generally given in millimeters. So you might see something like there's a 60% chance of precipitation today, 1 to 5 millimeters of snow. And when we talk about precipitation, it's anything falling from the sky. So snow, rain, hail. When we talk about wind, you're typically given a direction and a speed. So you might say we're going to have wind traveling from the west at 10 kilometers an hour. You might see something like a relative humidity of 90%. Humidity, we're just talking about the amount of water moisture in the air. When we talk about atmospheric pressure, you might see it in a couple of different units. We have atmospheres, bars, and then kilopascals. You might see the atmospheric pressure for today is 101 kilopascals. And then, of course, will it be foggy, misty? Is it generally sunny? Is there some cloud cover? All of those things help us define the weather. So if you were to look outside today, you should be able to give me most of those. It'd be hard to calculate humidity or wind speed, but you should be able to find those terms very easily and then use those to describe the weather on any given day. When we talk about climate, however, we're talking about the average weather in a region over a period of time. So the temperature of a region gives us the temperature range at different times of year. We talk about the type and amount of precipitation we might expect, what the winds will be like generally in any given season. To get an idea of an area's climate, we typically take about 30 years worth of meteorological data. The climate in a region also kind of gives us an idea as to what the plant and animal life might be. So a reason why we have certain trees or animals in Ottawa is because our climate is different than, say, if we went down to the Dominican Republic. If we talk about where we're generally situated, so kind of southeastern Ontario, we would say that here the climate is generally warm and humid throughout the summer, cold and snowy throughout the winter. That's just a general idea. We can get a little bit more specific, but you should be able to identify our climate as a general for a general time period. Obviously, it changes drastically. The climate here in July is much different than the climate in January. So as a general rule of thumb, weather describes the conditions in a very short period of time, days or weeks, whereas your climate is going to describe the type of weather you might expect in a region based on an average set of data. So if we look at this world map, we can see the different climate zones. So this is a figure straight out of your textbook. It separates the planet into these climate zones. If you take a look at Ottawa, you'll see that we are in the continental zone. This is described as an area where our summers are generally cool, which is, again, it's all relative, right? It's relatively accurate compared to places closer to the equator, for example, who have these very hot summers, or places in the southern United States or central United States. It's interesting to note, though, that our climate in Ottawa is very similar, as an example, to the climate found in some parts of Eastern Europe and Southwest Russia. So it's all of that, the middle colored blue. So if you take a look at the left of your screen, warm summers is dark blue, subarctic is this very light pale blue, and this cool summers in the middle there. The climate is dictated by a whole bunch of different factors, so it should, once we get to the next slide, it's not surprising why parts of, let's say, northern Quebec have a different climate than Ottawa, even though they're not too far from each other. It's only a couple hours. So if we talk about what affects our climate, we can talk about our latitude, which is the distance we are from the equator. So we start at the equator being 0 latitude, and then moving up or moving down from there. The ocean currents that are present if you're near a body of water, if you're far from a body of water. Wind and air currents, which can be dictated by bodies of water again, as well as mountainous areas, can dictate the wind and air currents in a particular region. Your elevation, which is defined as your altitude or your height above sea level. So if you're down at sea level, your elevation is 0, and then the more mountainous terrain or the higher you are from there, you're going up generally in meters or kilometers. And then we talk about the relief of a region, or the land formations of a region. So flat lands like the prairies are going to have a different climate than, let's say, the Rocky Mountains out in the west coast of Canada. So let's get back to the original question posed at the start of our lesson. Why do you think that climate change is occurring even though we can't predict the weather next week? Well, hopefully you have an idea of the difference between weather and climate. If we take an average of the weather in particular regions, or if we take the entire planet as a whole region, we can very conclusively say that the temperatures on average are increasing. So the climate's increasing, or the climate is changing. The weather is harder to predict because it's a little bit more specific, right? When we talk about weather, we want to talk about what's the exact temperature down to a degree. When we're talking about climate, we're just generalizing a little bit more. So we can say, on general, the climate is changing. The planet's getting warmer, the ice caps are melting, but whether we don't need to be that, or we need to be a little bit more specific, which is why it's hard to predict the weather tomorrow. We know it's going to be kind of cold, and there'll be snow on the ground, but I can't tell you for certain. Will it be -10, -5? Will we get any snow? What will the humidity be like? So that's it for our introduction to weather and climate. Hopefully you had the opportunity to fill out the notes. If not, you can replay this video easily, fill out those notes, and we'll see you at the next lesson.